This video will demonstrate how to use a separatory funnel. A separatory funnel is a piece of glassware which will allow you to separate two immiscible liquids on the macro scale, as you will have to do in a liquid-liquid extraction. So say I just did a reaction in an organic solvent. There's likely going to be some unwanted reactants or undesired products in your reaction solution. To get rid of them, you may do a liquid-liquid extraction with water as your extraction solvent to get rid of them. To do this, you will need a separatory funnel. So here is the top stopper, and here is the bottom stopcock, which will actually allow the liquid to drain out of the separatory funnel. This is the closed orientation, and this is the open orientation. You may secure a separatory funnel with a ring clamp on a retort stand. This should be performed in the fume hood, however, for the purposes of this video, I'm doing it on the lab bench with solvents which aren't harmful. Before you pour any liquids into your separatory funnel, make sure the bottom stopcock is closed. You may now pour your reaction solution into your separatory funnel. To minimize the loss of product, you should rinse out your reaction vessel. Since my solvent for my reaction was organic, I'm going to use an organic solvent to rinse the reaction vessel. If it was aqueous, use an aqueous solvent. Here I'm using ethyl acetate. And you should also rinse the funnel. Now I'm going to wash my organic layer with water. To do this, I'm going to use 3 15 milliliter portions. More smaller washings is better than large, fewer washings. I know that water is more dense than ethyl acetate, so water is going to sink to the bottom of my separatory funnel. However, if you're unsure of this, you may perform a water drop test to figure out where is the aqueous layer and where is the organic layer. To do the water drop test, take a pipette and pipette in a drop of water into your separatory funnel, and then watch where the droplet falls. If it just mixes with the top layer, then your aqueous layer is your top layer, and if it falls to the bottom, then your aqueous layer is on the bottom.
Yeah.
For the extraction to be effective, you're going to have to maximize the interactions between the two layers. To accomplish this, you're going to shake the two layers within the separatory funnel. To accomplish this, first take your separatory funnel out of the ring clamp and put on your top stopper. To actually shake it, I'm going to show you how to do this inside of the fume hood. To shake the separatory funnel, secure the top stopper with your index finger and hold it as I'm doing here. You're now going to shake it, so invert the separatory funnel and point it away from yourself and others. Generally, you just point it towards the back of the fume hood, okay? And then just shake, okay? There's going to be pressure building up inside of the separatory funnel, so you'll want to relieve this pressure by just opening the stopcock. And repeat this process a couple of times until you no longer hear any vapor escaping when you open the stopcock. Doing this 2 or 3 times should be sufficient. Shaking the separatory funnel can sometimes be messy and you can kind of clog the stopper. So one method you can do to avoid actually having to shake the separatory funnel is just to pour your solution out into an Erlenmeyer flask. and then shake the solution inside of the Erlenmeyer flask. You can either do this by swirling, as I'm doing here, or with a stir bean on a hot plate. And when you're done stirring it, you can just pour it back into your separatory funnel. An emulsion is an area between the two solvents where the two solvents are mixed together. In order to be able to effectively separate the two solvents, you're going to have a distinct dividing line between the two solvents. So before you separate, you have to wait for the emulsion to settle. You can see now that the emulsion is settled. Once you can see a distinct dividing line, you may begin to separate your two solvents. Place a clean collection flask, most commonly an Erlenmeyer flask to minimize solvent loss, under your separatory funnel, and lower your separatory funnel so that the tip of the separatory funnel is touching on the inside of the Erlenmeyer flask. Go. Remove the top stopper. If the top stopper is not removed, the liquid won't be able to drain out, and then open the bottom stopcock to allow the liquid to drain out. Okay. You're going to have to be able to recognize the exact moment when the water has completely drained out of your separatory funnel. When the stopcock is completely open, that's pretty difficult to do. So as the solvent begins to drain out, as it gets towards the end, only partially open the stopcock to allow for a slower flow. And then as it gets even more towards the end, you may want to do this dropwise. I can now see that there's no longer any water in the separatory funnel. Since the product is supposed to be in the ethyl acetate layer, it's okay to lose a little bit of ethyl acetate in order to ensure that there's no water within the ethyl acetate layer. I'm now going to repeat this process 2 more times. So I'm going to take another 15 milliliters of water, add it into my separatory funnel, shake and extract, and then do this a 3rd time to complete my extraction. Collect all of your water layers into the same flask. You should keep both layers until you are absolutely certain to which layer your product is in. I know that my product is in the organic layer, so I can discard my aqueous layer. Often you will need your organic layer to be completely dry. You can use a drying agent such as sodium sulfate to accomplish this. In order to do that, make sure you first transfer your solution out of your separatory funnel into a clean collection flask to add the sodium sulfate. If you add the sodium sulfate directly into the separatory funnel, it could clog up the stopcock, and that is difficult to clean. In this situation, your product was in the top layer, so it was very easy to drain out the extraction solvent, which was heavier than the organic solvent. Another very common situation is when your product is going to be in the bottom layer and your extraction solvent is going to be lighter than the layer to which your product is in. If that's the case, drain out the bottom layer as we've done here, and then you're going to have to get a clean Erlenmeyer flask and drain out your top layer, which is your extraction solvent. Once that's drained, you're going to have to put back in your bottom layer into your separatory funnel and then do another extraction. This process will be much longer, but it is necessary. In almost all cases, water is going to be heavier than your organic solvent. This isn't true, however, for chlorinated solvents such as dichloromethane, because the chlorine on the solvent makes it much heavier than water. For those situations, your organic layer is going to be your bottom layer. If your stopcock is particularly dirty, you can easily clean it by unscrewing this plastic nut here, taking off the rubber O-ring and the washer, Then this entire unit can easily come out to be cleaned. To reassemble it, the thing to go on first is your washer, your rubber O-ring, and then the plastic nut. This can be tightened or loosened to facilitate the spinning of the stopcock. It should be fairly tight to avoid any leakage. You add the reaction solution into the separatory funnel and rinse the reaction vessel into the separatory funnel. Add in the extraction solvent and shake the separatory funnel, venting away from others between shakes. Drain the bottom solvent, quickly at first and then gradually decreasing the flow rate to a drop to remove the last few drops of bottom solvent. Perform this extraction twice more. If your product is in your organic layer, you must first dry it before rotovapping. To do this, first remove it from the separatory funnel and then add your sodium sulfate.